For this next video, we're going to be talking about the segments of secants theorem and applying that to find some segment lengths. But first, we're going to go over some vocabulary. So we have three different types of segments that we're going to talk about. First one is a tangent segment, and that is a segment that is tangent to a circle at an endpoint. So I see here in blue that AD is a tangent segment. That's because it is a segment, so it has two endpoints, and one of its endpoints is tangent to this circle. Then I have something called the secant segment, and what that is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. So I want to see here that AC is a secant segment. And that is because this segment contains the chord BC. However, one of its endpoints, A, is outside the circle. So that's what makes this a secant segment. And then lastly, we have something called the external segment. And that is the part of a secant segment that is outside the circle. So I see that AB right here is my external segment. So keep this visual in mind as we go into this theorem, because we're going to be talking about all three types of segments here. And so this theorem tells us that if two secant segments share the same endpoint outside a circle, so I see here that EC and EB are both secant segments because they contain the chord and their endpoint is outside of a circle. And I see here they're both intersecting at E. This theorem tells us then the product of the lengths of one secant segment equals the product of the lengths of the other secant segment and its external segment. So looking at our diagram right here, what this is really telling us is that my external segment times my secant segment, so for EC, that's going to be EA times the whole thing, EC. So I have EA times the whole segment EC is going to equal to ED times my secant segment EB. So now let's go into some examples of applying this theorem. So at first I want to find the value of x. I see that I have two secant segments. I know they're a secant segment because this segment RQ and RT, they both contain a chord and they have an endpoint outside of the circle, and I see they're both intersecting at the same point R. So that means I can use my theorem. And again, my theorem told me that I'm going to take the product of the external segment. So here that's going to be RP times the secant segment, which is the whole thing, so RQ. And that's going to equal the same thing on the other side, so RS, my external segment, times my whole segment, RT. So RP I see is equal to 9. RQ, on the other hand, is going to be 9 plus 11. So to get that whole length, I need to add these two smaller segments together. So it's going to be 9 times 9 plus 11 is equal to RS, which is 10, times all of that added together, so 10 plus X, to get that full segment length of RT. Well, 9 plus 11, I get 20, so I'm going to have 9 times 20. It's equal to 10 times 10 is 100, plus 10 times x, which is 10x. 9 times 20, I get 180. Subtract 100 from both sides. And I get 80 is equal to 10x. And then divide both sides by 10, and I get that 8 is equal to x. Okay, let's try another one. So here I want to find the value of x. Again, I see that I have two secant segments here because they both are segments that contain a chord, and the endpoint is on the outside of the circle, and they intersect. So I know I can use my theorem that we just learned about, and that is that I'm going to have my external segment. So looking at my top segment here, my external segment is 3, so I'm going to have 3 times the whole segment, so I'm going to need to add these together, so 3 plus x plus 2, and that's going to equal to my external segment, which is x plus 1, times the whole segment, which is x plus 1 plus x minus 1. So simplifying in this first parentheses, 3 plus 2, I get 5, so I'm going to have 3 times x plus 5. And then simplifying here, I have x plus x, which is 2x. 1 minus 1 is 0, so those cancel out, so I just have a 2x right here. Then distributing, I have 3 times x, I get 3x. 3 times 5, and I get 15. It's equal to 2x times x, which is 2x squared, plus 2x. And so now I see I do have a quadratic equation here, so I'm going to need to use my quadratic formula to solve this. However, in order to use my quadratic formula, I need to move all of my terms to one side of the equation, and I'm going to move them to where my x squared term is. So I'm going to subtract 3x and subtract 15. And so I have 0 is equal to 2x squared minus x minus 15. And I'm going to use my quadratic formula. So x equals negative b. My b here is 1, so I'm going to have opposite of that. So 1 plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is negative 15, all over 2 times a, which is 2. And so I got my a, b, and c by looking at the coefficients in front of those terms. So now I'm going to go ahead and simplify it under the radical. 4 times 2 is 8. 8 times 15, I get 120. And so I'm going to add 1 to that. So when you simplify inside there, you should get the square root of 121. And the square root of 121 is 11, so I'm really going to have 1 plus 11 over 4, 1 minus 11 over 4. 1 plus 11, I get 12, divided by 4, I get 3. 1 minus 11, I get negative 10. Negative 10 divided by 4, I get negative 5 halves. And so I do end up with 2 different answers. However, I need to pick the one that makes sense in terms of the problem. And since I can't have a negative length or distance, that means my answer is going to be the positive one. So x is just going to equal to 3. If you need more review on quadratic formula, I do have a video posted after this lesson.